Hello, this is Misha Kim from MATLAB Germany, and this is the MATLAB and Simulink Racing Lounge. I have with me today's presenter Christoph Hahn, also MATLAB Germany, and he will talk to us today about CAD import in SimMechanics. Christoph?
Perfect, thank you. Hi together, let's start. As most of you are using CAD software, we thought it's beneficial for you to have a session on how you can bring your CAD assemblies to Simulink and SimMechanics in particular. Many teams use MathWorks products, especially when it comes to modeling of electric powertrains or developing control systems. For design of the vehicle suspensions, teams commonly use SimMechanics, and this is the tool that we focus on today. CAD data can be imported from supported platforms using SimMechanics Link. I will show you in a demo how to do that. For other platforms, there are also options to import CAD models. And furthermore, Simulink supports a number of third-party tools for comfortable data management. What is SimMechanics Link? SimMechanics Link, SMLink, is used to import a CAD assembly into SimMechanics. It's a free add-on to MATLAB, and basically your CAD data is converted to an XML file and then imported to SimMechanics. Masses and inertia are imported as rigid bodies, and wherever you have a joint in your CAD data, you will have a joint in the SimMechanics model. This brings me right away to the demonstration of the import of a double wishbone suspension system from SolidWorks. I'm gonna open the model at first in SolidWorks. Here we go, the assembly. Here you can see the double wishbone suspension, including a damper. The export to SimMechanics is pretty straightforward. Just click on SimMechanics link in the toolbar, export, and today we're gonna export it to SimMechanics second generation. Double underline wishbone, folder is correct. You already see that it's an export in XML format. So here we go, save. After we receive that message that export is complete, we can go directly to MATLAB and import our model. What we can see here is suspension export, that we have all the parts and the assembly is written as an XML file. The import command is SMimport, and then we just type the name of the XML file. Now the model is loaded into SimMechanics. And here we have a complete model of the double wishbone suspension already in Simulink. In order to have a more realistic behavior of the suspension when I'm gonna simulate it, I will add a spring stiffness and a damper coefficient to the model, which can be under set, prismatic primitive, and then internal mechanics. Okay, and then just after importing it, we are ready to run the simulation. Now the model is solved, and the result is visualized in the Mechanics Explorer. I'm gonna let the simulation run. And what you see here is a movement of the simulation. Basically, it's the weight of the suspension acting against the spring force and the damper force. I will rerun the visualization. So, with that simple example, you have seen how easy it is to bring your CAD data into SimMechanics and perform first easy simulations. This brings me back to the presentation. The installation of SimMechanics Link is pretty straightforward. You just download it from our website and install it. Again, it's an add-on to MATLAB and it's free of charge. The only thing is that you have to register it with your CAD platform. Step-by-step instruction to all that can be found on our website, or just by typing doc space smlink to your MATLAB command window. I want to recommend some videos on that, basically two videos. One is about importing and merging CAD models. It especially deals with making updates on CAD as well as on the Simulink side, and this video shows how to merge these changes and update your model in SimMechanics. The second video I recommend is more sophisticated investigation of the model you've just seen. Apart from importing the suspension into SimMechanics, a tire model is added and some tests are automatically conducted using MATLAB. Now coming to the hard facts, basically we have supported platforms such as SolidWorks, Wildfire or Inventor, and platforms which are currently not supported like CATIA and NX, and we have options for all of these platforms to import your CAD data into SimMechanics first generation or second generation. The first way, as I've shown you in the demo, is using SimMechanics Link, where you can import your model directly into SimMechanics 1G and SimMechanics 2G. The only difference is the command to import, which is either SMimport or mech_import. Another thing that has to be stated is that the update option is just available for SimMechanics 1G. The second option is to convert your CAD data into a step file and either export it directly to SM2G or go via a supported CAD system in order to import into SM1G. You can use SimMechanics Link API. It's an application programmer's interface to enable export to SimMechanics first generation, or use CAD scripting to create the XML files for import into SimMechanics second generation. I will provide you with some further information on that. The last option I want to present today is creation of MATLAB data using CAD scripting, which commonly comes along with a third-party tool involved. With that option, you have a very comfortable creation of MATLAB data, parameterized your model, and it's straightforward to bring that MATLAB data into either SimMechanics 1G or SimMechanics 2G. On that side, I've provided you with some further information about, at first, the third-party tool. Here, just an example, it's MATLAB connector from CAD Nexus, and a link to an article on MATLAB Central about the API using, in that case, Visual Basic. This brings me to the summary of all that. As you have seen, there are several ways to bring your CAD data into SimMechanics. At first, it's SimMechanics Link. You can use step files, you can use the API scripting or CAD scripting, or you can involve a third-party tool. Which brings me to the key takeaways for today. So if you are using a supported CAD platform, use SimMechanics Links. It's straightforward and it's the predefined way on that. For other CAD platforms, there are third-party solutions as well as scripting interfaces available. And the way to go fast for you is, without any restriction, convert your CAD data into step files and then import to SimMechanics. Thanks a lot.
Well, thank you very much, Christoph, for this presentation. And I'd like to close the session with a couple of announcements. First of all, I strongly urge you to take advantage of our complimentary software offer. And if you do use our software, please include our logo on your team website to reflect our role as sponsor. For any questions you might have, use our MATLAB Answers online platform or our Formula Student email address. Thanks for watching and goodbye.
Bye bye. See you next time.